So we were saying all energy comes in all different forms. Kinetic energy is the energy of motion. Gravitational potential energy is the energy as um, because of the position of an object. Thermal energy is heat energy. Chemical energy is the energy in chemical bonds. For instance, when you burn wood or coal, chemical energy is released and converted to heat. Nuclear energy is the energy of binding energy of the nuclei in the nucleus of an atom. Electrical energy is the most useful form for us, which is what we use to run our electric motors and all that. And electromagnetic energy is the energy in radiation, like light, X-rays, and gamma rays, and so on. We talked about converting chemical energy to electrical energy. So, for instance, in a coal power plant, you burn coal. From the heat, you produce steam. The steam is what turns that loop of wire to produce electrical energy. Okay. All right. So we'll be talking about all of that. So again, we said energy cannot be created or destroyed. So from an energy perspective, everything we do in life, everything we do in life amounts to converting energy from one form to another. Okay. So that's all we're doing. We're converting energy from one form to another. Okay. We're not creating it or we're not destroying it. So this slide, for instance, shows you how we can convert one form of energy to another form. So, for instance, uh, the chemical energy in coal, uh, when you burn coal, that's what oxidation means, combining with oxygen. When you burn coal, some of it is converted to light, radiant energy. And what plants do is use sunlight, and via photosynthesis, they produce chemical energy. Okay, so that's what this graph is showing you, how one form of energy can be converted to any other form. So solar panels, so solar cells convert light into electrical energy. And so hopefully in the future we'll be getting our energy, a major source of energy will be solar panels. Okay, what do heat engines do? Heat engines convert chemical energy to motion. So that's what your car does, for instance. When you burn gasoline in your car, um, your car engine is converting some of that heat to motion, the motion of the car. So you're converting chemical energy to mechanical energy. So this is showing you all the ways of converting one form of energy to another. You saw that in the generator, the motion of the loop that was mechanical energy got converted to electrical energy. Okay. All right. So kinetic energy is the energy of motion. So if an object, for instance, your car is moving at velocity v, so the kinetic energy of your car is 1/2 times the mass of the car times its speed squared. If an object is rotating, the kinetic energy, then that object also has kinetic energy. Its kinetic energy is uh, 1/2 times something called the moment of inertia times its angular velocity squared. Okay. So anyway, kinetic energy is energy in the motion of an object. Potential energy is the energy that an object possesses as a result of its position. So for instance, if an object is if an object of mass m, g is the acceleration due to gravity, is at a height h above ground, then its potential energy is given by mgh. So you can think of this, the water in a dam, when that falls to the generator, that's how much energy it has released. Okay. Uh, so so for instance, when you when you drop a ball, for instance, the speed at the bottom will can be calculated using this formula. Its potential energy gets converted to its kinetic energy. Okay, so this formula, and if you solve for the speed, uh, the mass will cancel, and you can work this out, will be 2gh. So that'll be the speed of an object that has fallen to height h. Okay, thermal energy. Thermal energy is heat, is the random kinetic and potential energy associated with microscopic movements of molecules. So, and okay, so let me show you a little model. Okay, if you go to my website, go to the simulations, and let's see, uh, black body plus. All right. Where is that simulation? Buoyancy, buoyancy. All right, I can't find it right now. Let's see. All right, I guess we'll have to go back. Anyway, so heat is uh, thermal energy is the random kinetic and potential energy. So, so what we're saying is, okay, let me try. So if you have a gas molecule, you have gas molecules like this. These gas molecules will be moving quite fast. So in a room, for instance, at normal temperature, these gas molecules are moving in random directions at about half a mile a second. And that kinetic energy is what constitutes thermal energy. Okay. So what this formula is saying, the energy of a gas is 3/2 times the number of moles of gas times the gas constant times the temperature of the gas. And that's this, so ideal gas has only kinetic energy, and this random kinetic energy is what's called thermal energy. So in a liquid also, in a liquid, the molecules, so in a glass of water, the water molecules are moving about randomly too. The only difference between a liquid and a gas is in a liquid, the gas molecules are much closer. Uh, in a solid, uh, in a solid, the atoms are fixed, but they're vibrating at a given around their fixed location, and that's the kinetic energy the solids have. Now, liquids and solids have potential energy as well, and thermal energy is the combination of all of that. Okay. Now, what this formula is telling you is, again, so um, if you add Q amount of heat to a solid or a liquid, and M is the mass of the solid or liquid, C is the specific heat of the substance, the temperature of the substance rises by delta T, by that much. So if you have a solid of mass M, you add Q amount of heat to it, its temperature will rise by delta T, according to that formula. C is the specific heat of the material. So chemical energy, as we said, is chemical energy is the energy associated with chemical bonds. So, for instance, chemical energy can be released in exothermic reactions and absorbed in endothermic reactions. So exothermic reactions are reactions where energy is released. To make an endothermic reaction happen, you have to put in energy. So for instance, when you burn coal or wood, you're combining carbon with oxygen and energy is released, and that's an exothermic reaction. Photosynthesis is an endothermic reaction. You need the energy of sunlight to produce those chemicals, the food that the plants make. So energy released in combustion is the heat of combustion. So when you're burning something, you're reacting with oxygen. All right, so here are some energies. So you take coal and burn coal, meaning combining it with oxygen. What you're doing is you're releasing 32.8 megajoules, million joules per kg of coal burnt. So that's what. So this is the. So these are called heats of combustion. Okay. So the more energy you release, the better the fuel. That's the idea. Okay. So here's methane, which is a component of natural gas, the major component of natural gas. When you burn methane, you're releasing 55.5 megajoules per kg. So you can see that you're releasing more energy than when you burn coal, except that here's the problem. Methane is a gas and it's harder to transport. So it takes up a kg of methane takes up a large volume. A kg of carbon coal takes up very little volume. Okay. When you burn ethanol, so you make ethanol from corn, for instance, when you burn, and a lot of gasoline nowadays, you can get ethanol and gasoline. Okay, so when you burn ethanol, you're releasing 30 megajoules per kg. When you burn gasoline, burning octane, octane is a hydrocarbon, and the name comes from the fact that it has 8 carbon atoms. So, so that's the most important component of gasoline. When you burn octane, you get 47 megajoules per kg. Okay, so gasoline uh, is a is a good fuel, except that the culprit is the problem is you're releasing carbon dioxide. Okay, so now let's look at this. So here's why natural gas is a good fuel. So for 55 megajoules of energy released, you are only releasing one carbon dioxide molecule. Whereas when you burn gasoline, for the same amount of energy released, you're releasing 16 molecules of carbon dioxide. All right. So again, keep that in the back of your mind. What you want to do is release as little carbon dioxide as possible to get as much energy as possible. None would be better. None would be perfect. All right. So nuclear energy is energy associated with the bonds between neutrons and protons in the nucleus. Uh, Nuclear binding energy is about 1,000,000 times greater than chemical energy. What that statement means is when you burn 1 kg of carbon and you get that much energy, if you get energy from 1 kg of nuclear fuel, you would get 1,000,000 times more energy than that. Okay. So that's what that statement means. So, um, so in nuclear energy, you're converting mass into energy, and here is Einstein's famous equation that shows you the equivalence of mass to energy. Energy is mass times speed of light squared. Okay. All right.